this as short as I can. So we're going to look at multiplying and dividing in this form, in this polar / cis form. And we're going to look at some patterns that show up when that multiplication happens. So I'm going to flip over, jump right to here. As you'll see, I've already done some of these calculations for you to help kind of keep things going at a brisk pace. But my suggestion is when you do this, you guys, for this question is we're going to define A, B, and C in our calculator. And the way you define a term is you're going to hit A, and then you'll hit Control and the button directly above this like open square button. See, it's got a colon and an equal sign. And then you're going to type in your function here, or your complex number. It may give it to you in rectangular form. It may give it to you in this form. Either is okay. We just need it defined in our calculator. We'll look at this other form later. So A, B, and C are here on the paper, A, B, and C. And we're going to be looking for the modulus and the argument for each one of these. So look down here. The modulus is going to be 3.16 for A, 1.14 for B, and 4.47 for C. And then for the angle for each, again, it has to be in radian form or it won't necessarily run the calculations for us. We have 322, and then 0.785, and then together A and B, A and C, C and B, and then this final one, A, B, and C, you're going to get the following numbers. So A times B is 4.47. B times C, that's this one down here, is 6.32. And A times C, 14.1. And then the last one here is 20, okay? So what you might notice, or you might, if the numbers were friendlier to look at, is that when you take the modulus of A and the modulus of B, for instance, so 3.16 and 1.14, when you multiply those two numbers together, you get this number, 4.47. And A times C, 3.16 times 4.47 is going to give us 14.1, so on and so forth. So if I took the modulus of A, B, and C, 3.16, 1.41, 4.47, multiplied those things together, well, on your calculator, it would give you 19.9, but that's purely just an approximation error. It's going to be exactly 20. So one of the patterns that emerge when we multiply complex numbers together is that the modulus of A times the modulus of B is going to give us the modulus of A times B, which is nice, right? Like, so if these were friendlier, if this were, for instance, 1 long and this were 3 long, that when you multiplied them together, the new complex number would be 1 times 3, 3 long. Or if you took this one, let's say this was 2 and this one was 3, 2 times 3 would give you a new vector complex number, which is 6 long. Okay. The more interesting thing here, which is maybe less obvious, is that when you have these angles, right, argument, the argument of A and the argument of B, for instance, A and B, 0.322, 0.785, when you multiply A and B, you can just add these two numbers together. So these two numbers added together is going to be this. These two numbers added together is going to give us this one. These two added together is going to give us C and B. And if you took A times B times C and you figured out the angle of that new complex number, well, it would be the angle of the 3 already added together. Okay, so this number plus this number plus this number is going to give us this. So visually, what that looks like, I'll give you a really simple example, is if you had a little guy down here, and we're going to use degrees even though we're not supposed to because it makes things a little easier to look at. If this were 1 cis 30 and this guy were like 2 cis 45, then if you took, let's call this A and this B, different from this A and this B over here. But if I wanted to take A times B, I would get an answer of 1 times 2 makes 2. And so it would be the same length long as this one. And it looks a little longer there, but that's just because I'm not the best drawer. And then its angle would be these two angles added together. So if this is 30 and this is 45, well then this guy is up here is going to be 75. And again, I'm breaking the rules and using degrees because it's way easier to add those together. Okay. So generally what this creates as a rule is that if I take two complex numbers and multiply them together, their new magnitude is going to be the same as the two magnitudes independently multiplied together. And if I take two complex numbers, multiply them together, and I ask what's the angle / argument of that, well, it's just the argument of the first and the argument of the second added together. Okay. So if you were going to write a rule, you would say R1 times R2 cis theta 1 theta 2. Okay. What that would look like here, if we were going to multiply these together, we would just take 3 times 4 and we would have 12. And I'm going to be, oops, that's supposed to be a cis. And then I'm going to cheat and just say that together. Okay. Some examples of how this might be used is like if you wanted to do a bearing question, right? Let's say you're moving along this trajectory right here, 7 plus 2i, and I want to turn 45 degrees. I want to go 45 degrees to the west. Then I could multiply by a complex number that has an angle of 45 degrees, or pi over 4. Again, just kind of playing with this a little clearly. So you might not be able to do this really like straightforward in your head, because why? Well, because this isn't the friendliest version, right? If I wanted to have the friendliest version of this, I would figure out what's its magnitude, which would be a squared plus b squared square rooted. So 49 plus 4 is going to give you the square root of, help me out here, friends, 53. And then cis, and I'm just going to say its angle is theta, times 1 cis pi over 4. So then our new bearing, our new trajectory we would gonna want to go along would be same magnitude here, same modulus, 53 cis, and then whatever your original bearing was plus pi over 4, because that's the same as 45 degrees. Okay? So that's kind of the one application you could look at. So this is a really common style question you're going to see here on your unit packet, as well as in mini IB style questions, which is the idea that if you have two complex numbers multiplying together and you get, so let's say that W is this new complex number, W, and W is created by taking 3 minus 3i and multiplying it by some new complex number z. And it's kind of asking the question, like, what has to be true about z and what has to be true about W if W raised to the first, raised to the second, raised to the third, raised to the fourth, so multiplying over and over and over and over again, instead of getting bigger or getting smaller, it stays the same size, right? Well, that would mean, right, if I have two complex numbers and I multiply them together and it gets neither bigger nor smaller, that those two numbers, right, the magnitude of this guy and the magnitude of this guy, they multiply together and you get 1, because 1 times itself doesn't get bigger, it doesn't get smaller, okay? So then these two together create W, and W is going to be R cis something. And we know that R, this guy's magnitude, has to be 1. It has to be consistently 1. Okay, well, if this guy, W, has a magnitude of 1 after I take this guy and multiply them together, those two complex numbers, then, well, let's just think of an example, right? Like if this guy's magnitude were 5, well, then this guy's magnitude would have to be 1 over 5, right? If this guy's magnitude is 12, this has to be 1/12, okay? So then that means we need to know what this guy's magnitude is. You can plug it in your calculator. You get 4.24, or you can do it by hand using Pythagorean theorem, and you get root 18. So if I had 1 over 4.24 and I multiplied it by 4.24, then I would get 1. However, this answer right here, this answer is no good to IB because it's 1 over a number with a decimal. So you'd have to actually run the calculations here, which would give you 0.236. Or you could say that, well, if this guy has a magnitude of root 18, then Z, who is also an R, we're going to say this one's A cis theta, right? A times this guy has to be 1. So, all right, you could just do it as a nice clean fraction instead. That would also work. Things to think about in terms of multiplication. Well, if multiplication creates like a forward rotation, then what do you think division would do, right? Well, here's our rule for multiplying, getting the sizes, right? It scales it up. So if I'm doing this and assuming that both Z and W are greater than 1, is you would get points along as you multiply it by themselves. Let's say they multiply by themselves over and they do it again and again and again and again. You're going to get a spiral because they're getting bigger and bigger and bigger. If I keep these two guys, I just keep multiplying them by each other over and over and over, well, it's going to get bigger. Well, let's say that these two are both whole numbers, right? So no fractions kind of messing things up, no numbers that are less than 1. In this case, instead of getting bigger, we're going to get smaller, right? So if this is 2 and this is 3, well, if I keep running this calculation over and over and like divide by 3 again, and divide by 3 again, and divide by 3 again, then it's going to get smaller and smaller and smaller. You're going to get something different, right? You're going to get this little inward spiral like this. So he's going to get smaller and smaller and smaller as time progresses, okay? That also means that if this guy is producing an angle that's growing, then this guy is going to produce an angle that's shrinking, okay? So for example, if I had, again, switching back and breaking the rules so we can use friendly numbers, if I had this angle right here, here's our complex number at 90, and here's another one that's at 60, let's say I have 2 cis 90 and 1 cis 60, then the resulting value is just going to be 2 divided by 1, 2, 90 minus 60, because it's going to pull that backwards and down, give you 30, okay? So if instead of having 3 times 4, we had 3 over 4, right? 3 cosine, I'll just write it as cis, 3 cis pi over 3, and 4 cis pi over 2, then our result is just going to be 3/4 cis, and instead of adding these together, we're going to subtract them from each other, okay? So common IB style question for this might be something like, if W is 3 cis pi over 3 and we divide it by r cis theta, okay, and we get this new guy, right? So W over r cis theta gives us this new complex number, and it's Z. And Z is also just making a circle. He's not getting bigger, he's not getting smaller. Well, don't trust my drawing. Just say he's not getting bigger, he's not getting smaller. So if he's not getting bigger and he's not getting smaller, then that means that Z has got to be 1 cis something. We don't even care, right? If we're just interested in what does this value R have to be to make this be a circle, that means that z has got to have a magnitude of 1, which means that r has to balance this 3 out, right? So what would it have to be to balance it out? Well, then this guy right here, he'd have to also be 3. So that would be a common style question you would see for either in your unit packet or on IB testing. Kind of finally, our last thing to think about would be filling out this chart, which is kind of like a big idea, right? So when you're thinking about complex numbers in general, big ideas, is it's knowing which form to pick to do which thing. So like if I want to add together 4 plus 4i and 3 plus 2i, well, it's really easy to do. The 4 and 3 go together, the 4 and the 2 go together, and you get a nice friendly number. Or if you want to subtract them, you could do it that way as well. So for rectangular form, adding and subtracting, nice and friendly. Multiplication, it's not the best. You know, you go along, you do all the pieces. It goes, but it's not the easiest thing. And it's not great if you have to do it repeatedly, right? If I wanted to take this number times this number and I wanted to do that 5 or 6 times, well, that's really going to get messy really fast. And division, it's got that complex conjugate thing, thumbs down, we don't like that, okay? But if you're in this other form, this cis form, well, addition, right, this is not great. So addition's not great here, but if I turn it back into this form, oh, that becomes friendly. If you have a calculator, doesn't really matter, you can just pop it in the calculator and it does it for you. Same thing with subtraction, right? If I have to do this by hand, I'm going to have to put it back into this form before I can add and subtract it together, because you can't just add these and subtract them together. They don't go this way, right? It's not like 3 and 7 when you add them together gives you 10. It doesn't work that way. But multiplying, well, multiplying in polar form is friendly. 3 times 7 is 21. If this is theta and this is alpha, we're just going to add them together. So whereas here it was not friendly, here things become very friendly. We're just multiplying and adding. Here, on the other hand, right, 3 over 7, just leave it as a fraction, and then we're just going to subtract these. So big idea here is knowing which forms are easiest for adding, subtracting, multiplying, and dividing. In terms of homework, here's what I want you to do. Make sure you feel comfortable putting these into cis form, okay? That would be just practicing using your calculator, putting them into cis form. Do make sure you understand how to put these into cis form without your calculator. If necessary, you'll always have access to your calculator, right? 3 plus 3i, that means these have to be balanced, and so this would have to be a 45 or a pi over 4. And then the magnitude would be 3 squared plus 3 squared, giving us 18. So this right here, for example, would be root 18 cis pi over 4 if you had to do it by hand. However, I'm not super worried about that. It does come up occasionally, so do know how to do it, but don't worry about doing all your practice that way. And then also this, making sure you feel comfortable taking it from cis form, plugging it back into rectangular form. So you would have to expand this all the way out, right? I did get some comments from people on the last video having a mistake, which was totally real. I missed the sign on the second term when I was plugging it in, which was my bad. So you would want to write that all the way out before you plugged it into your calculator. This form, not as easy going back into your calculator. We will learn one more form, which gets a little bit easier. And then the last thing here is just kind of thinking about, how do I multiply them? How do I divide them? I don't actually need you to do the subtraction and the adding. You could just do 6 cis pi over 2 minus pi over 6, and then 6 over 2. Well, that's just going to be 3, right? So 3 cis pi over 2 minus pi over 6. So running them out in quick hand form here. Again, probably focusing mostly on those unit packet style questions, and hopefully this wasn't too long and you guys are able to kind of understand. Feel free to email me or with any follow-up questions you might have regarding the lesson.